In this chapter, we're going to go over translate a verbal phrase into a mathematical expression. There are two objectives in this section. Let me go to the previous slide. The first one is translate words, phrases into algebraic expressions. And the second one, translate other word phrases. This summary is very helpful when you're working on your homework, and it will tell you the key words to keep in mind for expressing something as an addition, a subtraction, multiplication, and division. So make sure that you keep this handy when you're working on that. Example 1. This example, it is about translate the English sentence into an equation using variable. Use the T to represent the number of boxes carried on Thursday and F to represent the number of boxes carried on Friday. Something that I want to highlight is the word equation. So if you're setting up an equation, the key thing is that you must have an equal sign. Okay, so when it is an equation, you must have an equal sign, must be present. Later on, we're going to work with what is called expressions. And when you are setting up expressions, they do not have equal signs. So the first example here, it says, on Thursday, Adrienne carried 5 more boxes into the dorm than she did on Friday. Okay, seems that Adrienne has a lot of boxes. Anyway, just my personal opinion. Then, so the way we set this up, here is the solution. The number of boxes carried on Thursday is 5 more than the number of boxes carried on Friday. So remember that for Thursday, they recommended the variable T, which is a nice change from using X all the time. So Thursday used a lowercase t, as it was stated in the previous slide, and equals 5 more than Friday. So you look at the translation here, and it says, I'm clicking too much. It says T for Thursday equals 5 plus Friday, the lowercase. It will have also been correct if you choose to write T equals F plus 5. Okay, so that is another option, and it will still be correct. It will even be correct if you choose to rewrite it as 5 plus F equals T. But you tend to, and that is using the equality. You can have the equality on either side of the equal sign. But just the tendency is the way you read it, that's how you will create the equation in this case. So just try to follow the order in which it was given to you. Okay, so next, example number 2. Write an algebraic expression. Okay, so if it says an algebraic expression, you will not have an equal sign. Write an algebraic expression for Sally's trip and Melinda's trip. I think that's not correct, but Melinda's trip. Use the letter S. So Sally, they want you to use the letter S, and Sally and Melinda, they're going in a trip. Okay, so Melinda's trip is, you see, it was misspelled before. I didn't make this slide, I'm using Pearson's slides. Okay, Melinda's trip is 380 miles longer than Sally's trip. Okay, so Melinda's trip is 380 miles longer than Sally's trip. So you can pause the video and try to create an expression for Sally's trip and Melinda's trip. So they decided to use S to represent the length in miles of Sally's trip. Therefore, the expression that you will use for Melinda's trip is 380 miles more. So you assign a variable to the unknown that is connected with the data, with the expression that you're trying to set up. So Sally plus the 380 miles will give you that is the expression that you will use for the length of miles of Melinda's trip. Okay, but even though it has an equal sign, the expression itself is just S plus 380. Example 3. Write an algebraic expression for the height of each of two buildings. Use the letter M. Larson Center is 126 feet shorter than McCormick Hall. So Larson Center is 126 feet shorter than McCormick Hall. So we don't have McCormick's Hall height, but if we had it, what we will do is subtract 126 from it. So the height in feet of Larson Center is whatever McCormick Hall is that you don't know, and the Larson Center is 126 feet less. So you must know McCormick, that's why that is your unknown, and then remove 126 in order to get the amount in feet or the height for Larson Center. Okay? And you might have to pause and meditate on this one, but it is okay. We can do it. So next, example 4. Write an algebraic expression for the length of each 3 sides of a triangle. They want you to use the letter X. X is back. The second side is double the length of the first side. The third side is 6 inches longer than the first side. So, I'm going to read this again. So the second side is double the length of the first side. So the second side, in order for you to determine the length of the second side, you must know the first side first. Okay, you need to know that. Since you don't know that, we need to call the first side the letter X. The third side is 6 inches longer than the first side. So both of these depend on the length of the first side. So when we look at the solution, we are going to see that the one that you need to know in order to generate the other expressions is the one that will be assigned, in this case, the variable X. So let X is the length of the first side. We need it for the second side. We need it for the third side. The second side, it was stated in the previous slide that it was twice. So that means 2 times the length of the first side. The length of the third side, it was stated that it was 6 more than the length of the first side. So you can have 6 plus X, or you can have it as X plus 6. So the expressions is what you see to the left here. Example 5. Write each English phrase as an algebraic expression, and they want you to use the letter X to represent the number. And what they mean, let X represent the number, is really the unknown number that you're going to use, for which you're going to use the letter X. The sum of a number and 7. The sum of a number and 7. So we don't know what that number is. So whatever that number is going to be the letter X. And you put a plus sign because it says a sum. So X plus 7. And it can also be 7 plus X. But again, they prefer to follow the order in which it was given to you in the exercise. Next, 10 less than a number. 10 less than a number. So is 10 away from. Just to give you an example, if I am 30 years old, which it could be close to reality, the looks will be fine. So if I'm 30 years old and then it says, oh, somebody's 10 years younger than you, you will say 30 minus 10 is 20. So here, 10 less than a number, you have to get that number, call that number X, and then subtract 10. This is not the same as 10 minus a number, although it often gets confused and is the one that we tend to have the most mathematical technical difficulties. So it does require part B. Make sure you study that, and that's why I like to use, oh, if they were talking about age or I was talking about something, how will I write that down? So 10 less than a number, 10 less than 20, you will say, oh, 20 minus 10 is 10. So just try to create a mental example, and that usually helps me. So for the first one, the sum of a number and 7, x plus 7. 10 less than a number is x minus 10. Again, it's not the same as 10 minus x. It will not be wrong. It will be extremely wrong if you do 10 minus x. Okay? So keep that in mind and listen to me. Next, example 6. Write each English phrase as an algebraic expression. Let the variable x represent the number. Twice a number decreased by 6. Twice a number, they want you to use the letter x. So twice a number, 2x, decreased by 6. Decrease means minus. So that one should be 2x minus 6. D, the product of 8 and a number, 3 more than the quotient of a number. Okay, so you can pause the video and try to set those up. I'm sorry about doing letter C already. I just got excited. But you can do D and E. You can pause the video and then you can move up to the next slide. I should have a bell or something. I'll work on that. Next. So solution. For the first one, twice a number decreased by 6. Twice means 2 times. So 2x, decrease is a subtraction, 6. I like that one because it's the way you read it, that's how you set it up. D is also beautiful. The product of 8 and a number, 8 times x. We do not express the multiplication when you're working with algebraic expressions. The multiplication in this exercise, 8 is called a coefficient, and is they prefer to leave it implied. So 8x, it is implied that it means 8 times x. E, 3 more than the quotient of a number. Ooh, that's a big one. So 3 more means, okay, I'm going to have an addition here. So plus 3, 3 more. And the quotient means division. The quotient of a number, we don't know what that number is. So the quotient of a number, and it should say an 11. It seems that they missed a part here because I see that it says x over 11. So the quotient of a number, what is after, that will be the numerator, and it should have said an 11. So an alternative to this, it could also would have been, because it is addition, you can express it as 3 plus x over 11. That would have also been correct. Or the x over 11 plus 3. So next. Oh, wow. Look at this one. So this one are the other symbols that are going to include the equal sign, not equal to, greater than or equal to, or greater than. So this one you might not want to admit, but if you are able to remember this with alligators, or when it opens to the largest number and it closes or points to the smaller number. So let me go over these examples that might help you get this a better idea of how they're going to show up in your homework. We'll look for the first one. The is exactly is a key word for is, for an equal sign. The measurement of the particle m is exactly 22 millimeters. So m equals 22. The next one is not. So it's an equal sign with a bar through it. The number of broken glasses in the shipment G is not 10. So G does not equal 10. And that's good. That did not that many broke. Okay, at least greater than or equal to. So if it has the phrase at least, it implies that or more. The number of tickets sold S must be at least 190 for the show to go on. So that means if they sell 190 or more, it could be that is the amount of tickets that can help the company break even. So it says you need 190 or more tickets. So that's why the sales that they are using the letter S must be greater than or equal to 190. So it will be S is greater than or equal to 190. You always read it from left to right. Next, is greater than. So the moment that you remove that bar, that means that that number on the other side, on the right-hand side of the inequality, is excluded. So John spends S more than $100 on eating out. So that means S, spending, is more than, so is more than $100. So it's not 100, it's more than 100. Next, then we have less is less than. So this one points towards the left. The amount of gas in the tank G is less than 2 gallons. So the gas is, you read it from left to right, the gas is less than 2. At most, that means the speed of the wind is at most 73 miles per hour. So at most, that means that it's not more than 73. So is between. So between will represent double inequalities. The number of ducks in the pond, D, is between 9 and 18. So again, when you have the word between, it should inspire you to double inequality. The smaller number on the left, the larger number on the right, and the variable will always be in the middle. So it's between, and when it says inclusive, that's when you have the double inequalities and they both have equal signs. So the key word here is inclusive. We didn't have that word in the other one where it says is between. So the word inclusive will indicate that both inequalities will have to have an equal sign. Is approximately. So the number of people at the concert in the park, P, is approximately 517. So this is just a notation. I also call them squiggly, and it's also called, I believe, tilde. Squiggly lines. Example 7. Write each English phrase as an algebraic expression. The cost to rent the hall for the banquet C is exactly $700. B. The number of players in the field, P, is not 17. The number of empty seats on the plan, S, is at most 21. D. The temperature today, T, will not exceed 86 degrees. Again, I recommend that you pause the video, try it first. Okay, I call that, we want to make sure that you're digesting the information. Then you click and you will say, oh, maybe, oh, I got them all right, or I need to work on some of this. It just helps your learning process. Next, solution. The first one, C equals 700. Second one, P is not equal to 17. C, S is less than or equal to 21. D, T is less than 86. Again, if you did not get these ones right, don't worry about it. Just go back and try it again. Next, example 8. Translate the verbal phrase and interpret, letting N represent the value or the values. 5 pence or less. Choose the correct answer below. So if you look at the first one, 5 pence or less, you can have, before we answer, if you have 5 pence or less, that means that you have 5. You can have 4 pence. You can have 3 pence. You can have 2 pence. You can have 1 pen, and you can also have 0 pence. But can you have negative pence? No, there are no negative pence. They don't have, negative attitudes. Some of them may. So we can go ahead and eliminate letter C, because letter C, it says that you can have negative pence. So C, you are out. B, it says that you can have that the amount 5 pence or less is 5, 6, 7, 8. That's going in the wrong direction. Less means less than 5. So B, I am so sorry, but we have to say goodbye to you too. So now we have to decide between A and D. The difference between A and D is that D, it says, oh, okay, so you have 5 pence or less. That means that you can have 1 pen, 2 pence, 3 pence, 4 pence, 5 pence. But it is also forgetting that you also may have no pens. So that's why you cannot answer D. And the only answer is letter A, because letter A takes into account, and this is based on real life. So can I have 0 pens? Yeah, you can have, that means no pens, so it's an empty set. So that's why the correct answer is letter A. So that's it for this video. It was such a pleasure to read these slides to you, and I hope you learned something.